Hi everybody, and welcome to your first video lesson for grade 12 advanced functions. This first unit is just titled functions. And this first lesson, really easy, just a review and preview of some grade 11 stuff. Now hopefully you made it through the orientation activities okay. If you haven't done those yet, please pause this video, don't start the actual content yet of the course. Do those orientation activities first. And just so you are aware, this unit is the longest unit of the course. It's going to have the most lessons attached to it. And so you're aware, you have your very first test coming up this Friday afternoon. And remember some of those how-to videos that describes how tests are going to work on D2L. And I will give you a further update maybe on Wednesday or Thursday. I'll post a quick little video just to remind everyone and go over the expectations for the test on Friday. And if you've read the CIS, the course information sheet, we have 7 units, 7 tests, 10% per unit, obviously 70% for the term, which means, excuse me, each one of your unit tests is going to be worth 10% of your mark. And if I'm planning this course, or at least I'm hoping to be back in the building, but we're planning the course like it's going to be fully online. If we do get back to the building, which again, fingers crossed, we're back at school, back at HT sooner rather than later, then there'll be some other assessments sprinkled in on top of your tests. But for now, just 1 test per unit while we're online. Keep it simple. So our learning goals for this first lesson, again, it's a review of grade 11 stuff. So review function versus relation, review the different representations of functions, review function notation, and review domain and range. And before moving on, while I think about it, I mentioned some of the how-to videos, but how you tackle these lessons is completely up to you. So if you want to listen to it once on your own, and then listen to it again on a quicker speed and copy things down if you want, you could alternatively download the lessons that are already filled out on D2L and then just have those with you while you listen to this. Pause the lesson, write down the example, listen, pause, copy kind of idea. It's really up to you. It's totally up to you to figure out what's going to work the best for you. And then remember, there's going to be drop-in team sessions twice a day for roughly like an hour and 15 minutes each day. There won't be any lessons specifically. That way you can do things on your own time. And that way too, if you need to back up or whatever, rewind and listen to it again, that's a good learning tool for you. So there's drop-in team sessions twice a day. You can find those in the activity feed on D2L. Just click on it. If you have a question, you want to reach out to me, that's just another way that you could get a hold of me with those team sessions. You can drop in, ask a question, I can give you a real-time answer, and then you can drop out. And then later in the day, if you have another question, you can also drop in again, drop in and out as many times as you need. And if you need one-on-one help, we can do a breakout room in Teams, whatever you need. So it's totally up to you to figure out kind of what works. Plus, don't forget, hopefully you took my advice, you downloaded the Hasia app. That's a great way for you to get into contact with me, ask me questions, send me pictures of questions. You can use the discussion forum, which again, I encourage everyone to use the discussion forum under communication to not only post questions, but answer other students' questions. And that's another way that I can provide assessment to you as well in addition to your tests. So lots of different ways. Plus you can email me. Okay, so enough about that stuff. Let's get into the math. So function versus relations. So recall from grade 11, a function is a set of ordered pairs that has a unique relationship such that for every value of x, there's only one unique value of y. In other words, x values cannot repeat, which graphically you would have seen something like, hopefully your teacher mentioned it, which was must pass the vertical line test. So if you hold up a straight edge, a ruler, let's say, and you hold it perfectly vertical, if it doesn't touch that pencil or ruler twice, then it passes the vertical line test. It's a function. If it touches it more than once, it is not a function. We're going to do a bunch of examples. To review our function notation, so remember that you're going to see stuff like this. So f and then brackets has an x in it, and you read that as f of x, or some people read it as f at x. So our first example, we're just going to keep it simple here. Function y or y not. And let's call this a and this b. So if we look at a, it's a graph. It makes sense to use the vertical line test. So if you were to hold a ruler or a pencil up against it, does it touch it once or more than once? So I'm just going to draw a line in here since obviously you can't see me hold a ruler. But let's say I draw a straight, assuming that's straight, up and down. My circle touches it twice. If it touches it more than once, remember, not a function. So you want to say not a function. And you have to say why. So not a function, and you could say, I'm going to short form here, does not pass vertical line test. Not a function, does not pass vertical line test. Looking at B, if you were to draw a straight line on there, vertically, and remember, not just in one spot, you got to kind of move it left and right, but that's just a straight line, and if you move it left to right, that does not touch that red line I drew there, doesn't hit your ruler or pencil more than once, therefore it is a function. So is a function, and don't forget about y, and we'll just write passes vertical line test. Simple as that. And we have one more there. So we'll call this C. So the first two are pretty easy. They're just graphs. C, I've given you a set. So there's a bunch of ordered pairs. And remember from our definition, all that matters is x's cannot repeat. So, I mean, you could take the time to graph those 6 points if you really wanted to, and see if it passes the vertical line test. But ultimately, it boils down to, do any of the x's repeat? So if you go through each of our coordinates, 5, 12, and if I look over here, so if I look at this one right here and look at this one right here, 512, 572, my x's repeat. Already we know it's not a function. You could keep going with this, and we actually have another set of repeating points, 1025, 1055. The x coordinates repeat with the tens, so just another example of why it's not a function. So not a function, and y, we could say, you could, if you did graph this, you could say it does not pass vertical line test. Since I did not graph it, I can't say that. So we're going to say not a function because x values repeat. And we can even be more specific. The repeating ones were x equals 5 and 10. So that was A, B, C. We'll call these D, E, F, and G. And let's put arrows on the end. just to show that it keeps going. Not that it matters. So if we look at D, since it's a graph, D and E are both graphs actually. Do your vertical line test, hold your pen or pencil, ruler, straight up and down. Does it touch that more than once? For D, as I hold my straight line up against there, and if I move it left to right, it only ever touches it once. So function. And the Y passes vertical line test. E, straight edge, straight up and down. Already it hits it more than once, therefore not a function. And Y does not pass vertical line test. F and G, hopefully you've seen those before. They're what's called a mapping diagram. So if you have forgotten that, we'll make a little note here. These are called mapping diagrams. And the first bubble is always your X, and the second one is your Y. So what this means is that, like, if you start on the left, -1, -1, 5 is a coordinate. 0, 3 is a coordinate. 1, 5 a coordinate. 2, 11, 3, 21, those are coordinates. And really what it means is, like, it's called a mapping diagram because you'd read this. -1 maps to 5, 0 maps to 3, 1 maps to 5. So remember, you could graph these, I'm not going to, but X's can't repeat. So if I look, I have 2 arrows heading to the 5. That's okay, that means Y repeats, 5 repeats twice for Y. What you're looking for with mapping diagrams is, do you have more than one arrow coming out of an X? So if I look, -1, 0, 1, 2, and 3, they only have one arrow coming out of each one of them, which means X does not repeat, which that means this is a function. So F is a function, and don't forget Y. And again, since I didn't graph it, I can't say passes vertical line test unless you choose to graph it. So we're just going to say X values do not repeat. Knowing that information, G becomes a lot easier. Who cares that the Y is letters? Really all you're looking for is there more than one arrow coming out of any of the X? And the answer is yes. If I look at the 3 maps to B, 3 also maps to C, which means X values repeat. Therefore, not a function. Not a function, and Y, this one would be tough to graph. I mean, you could, but not a function, and we're just going to say X values repeat, and being more specific, X equals 3 is what repeats. Domain and range, so this is going to be a quick review for notation. So when we're talking about the domain, so domain, and now is your chance to practice your best curly brackets. And don't forget, domain only has to do with the X coordinates or the independent variable. So X, that E looking symbol, and then a capital R, and then a line, and then you fill in after that what you need to fill in. It completely dependent on the function, how you write that. Usually with inequalities, but sometimes you can list the coordinates. And we're going to do some examples. So that's domain, and how you read that. So domain X, that little E means is an element of. So X is an element of, that double line capital R just means, so it's an element of the real number set That vertical line means such that, in case you were wondering how you read that. Our range, so capital R, this has to do with the y coordinates or the dependent variable. Curly bracket, y is the element of the real number set, such that blah, 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 whatever the function happens to be. And again, that's just a quick review for how you state your domain and range, which we are about to do for all of the functions that we just looked at. So we'll call this A, B, and C. So if we look at A, that's just a set of coordinates. That means that, in this case, relation, because it's not a function if you remember from earlier, that relation only exists at those points. So you can't say that it's between 0, say x for instance is between 0 and 15, because it's actually not. It's only at 0, 5, 10, and 15. So kind of give the answer away. So for domain, capital D, colon, best curly bracket, and then since we're doing domain, x is the element of a real number. Now since it only exists at 5, 10, 15, and 0, we write it as x equals, and it can only equal these numbers. It doesn't matter what order you put it in. If you want to have fancy math form, usually you go in ascending order, so lowest to highest. So 0, comma, 5, 10, 15. If you wanted to list 5 twice and list 10 twice, you're more than welcome to. It wouldn't be wrong, but you don't have to. And then our range, y is the element of the real number set, such that, and this is just the y coordinates. So y equals 0, 12, 25, 37, 55, 72, 37, 55, 72. And there's A done. B, if you can't see it, let's just call that a 3 and a 3, -3, and a -3. So domain x is all real, such that now x only exists. So if you look at the domain, that's left to right, it only exists between those two kind of barriers, between -3 and 3. So how you write that, usually you start with the lowest number first, which is -3, less than or equal to x less than or equal to the biggest number, which is 3. So it exists up to and including those 2 points and everything in between. Our range, y is the element of the real number set, and same idea. Range only has to do with the y values, and my graph only exists between those 2 endpoints and everything in between. So lowest number less than or equal to y, less than or equal to the biggest number. For C, let's put arrows on the end to simplify it. Now remember, arrows means it goes on forever in both directions. So this is, as I go to the left, it's going to keep getting lower and more left. As I go to the right, it's going to keep getting higher and more right. It goes on forever in both directions. So this one's pretty easy. Since it goes on all the way to the left, all the way to the right, basically to infinity on both sides, negative infinity, plus infinity, this is just x can be anything. X is all real. Range. Same idea. ABC. Let's do. It keeps going in both directions. Y can be anything. It's not restricted. F and G. And for D, just to make life simple, we'll say that's 1.5, that's negative 1.5, and we'll put arrows on the end. So starting with our domain, those arrows means it keeps going on and on forever, so it's going to keep getting wider and wider and wider. So X is not restricted. X can be anything, so X is an element of real number. Range. Range has restrictions. My graph gets no, assuming it just keeps going down, or even if you just assume it repeats that pattern, doesn't really matter. The highest my graph gets is 1.5. The lowest my graph gets is negative 1.5, which means when it comes to the range, my graph only exists between those 2 points. So y element of the real numbers such that lowest number first, less than or equal to y, less than or equal to the highest number. Now, so, and by me writing like that, I'm assuming the pattern's going to repeat and not just keep getting lower and lower. If you wanted to keep those arrows going lower and lower and that pattern not repeating, meaning it's not periodic, it doesn't look like a sine curve or a cos curve, then it would be y is less than or equal to 1.5. But we're assuming that the pattern repeats. So I'm going to pick a different color here for E. So this is going to get purple. Again, we'll put arrows on the end, and to make life simple, 1.5, and we'll say that just goes to negative 1. So for my domain, I am restricted. So I only get as low as negative, again, I'm going to assume the pattern repeats. I only get as far negative as negative 1 and as far positive as 1.5. And then that periodic pattern repeats. So x is a part of the real number set such that, and then negative 1 less than or equal to x less than or equal to 1.5, close curly brackets. And just so you know, your curly brackets probably look a lot better than mine. Doing these with the pen on the computer is really hard, but I will practice. Now range, this keeps going on and on forever in both directions, up and down, meaning it is not restricted. So y can be anything. Oh, that was a good one. All right, if I take my time, I can do better curly brackets. It's a goal of mine. F, mapping diagram. Now, if you are tempted to say everything between negative 1 and 3 for your domain, don't forget that's x, that's y. I like where your head's at, but those are only coordinates. So like there is no 2.1, 2.2, 2.3 or anything like that. Those are the only 5 x coordinates. So we have to list them. So domain, x is all real such that x equals, and just list them, negative 1, 0, 1, 2, 3. Range, same thing. They only exist at those specific values. So 3, 5, 11, 21. And if you want to list 5 twice, you can, but you don't have to. It wouldn't be wrong if you did, though. And let's pick a different color here. We'll use black. So we'll do G in black. So same idea. Domain, all real numbers. Now we're not going to list 4, even though 4 is in the mapping diagram. It's just there to kind of throw you for a bit of a loop. But arrows only come out of 1, 2, and 3. So it only exists at 1, 2, and 3 on the x. Range, A, B, C, D. Now, even though A, B, C, D, they're not numbers, we'll just pretend like they are. Y is an element of the real number set, and then we'll say Y equals A, B, C, D. I know that's not technically true, but just to show you. So hopefully that's a good review for most of you on domain and range. I got one more thing I want to do before concluding this first lesson. So we have a function here, f of x, and I want to answer each one of these. This is function notation practice, f of 2, and then b f of 2x plus 1. So it's pretty easy. Hopefully remember what to do. If not, it's okay. I see an x here. Here I see a 2 where the x is supposed to be. All that means is put a 2 in wherever you see x. So f of 2 equals, wherever I see x, put a 2. Good idea to put it in brackets. And then you could use your calculator, you could do mental math. One thing you definitely shouldn't do, don't do 3 times 2 is 9 and then square that's 81. That's for, or sorry, 3 times 2 is 6 and 6 squared is 36. Definitely don't do that. What you want to do, remember BEDMAS, square, do the brackets, exponents first. So 2 squared is 4 times 3 is 12 minus 2 is 10. And then b here, wherever you see x, replace it with 2x plus 1. So 2x plus 1 squared minus 2. Again, don't distribute that 3 in first. Do the brackets. And if you don't remember, going back to like grade 10, to deal with the square, just write that 2x plus 1 side by side and FOIL. I'm going to cut to the chase here. After you FOILed, or if you know the shortcut for expanding a binomial, a perfect square binomial, then you should get 4x squared plus 4x plus 1. Now you can distribute that 3 in. 12x squared plus 12x plus 3 minus 2. And then last but not least, 12x squared plus 12x plus 1. So that's everything I wanted to cover in the first review lesson. There is no practice homework attached to this, so you could just move on to the next video lesson. And don't forget, these are going to be posted in YouTube, so you can also grab them in YouTube, refer to them anytime that you need to. If you have questions, let me know. Email me, message me in Hasia, drop into one of the Teams meetings. And remember, even though I have a schedule listed for you under the announcement feed, you kind of can go at your own pace, and attendance is going to be taken every day at the end of the day. To be considered present, you have to have like engaged in the course every day. Now, engagement usually is you logging into D2L between 9 and 3, but you could also engage by messaging me in Hasia during those hours, sending me an email during those hours, logging on to do a test during those hours. So anything that I can visibly see that you have done between 9 and 3 counts as you being present. And most of you already know all this since you've been in a virtual class at least once already, dating back to last year. So that's it. Have a good one. Hopefully this was okay for you, and you know what to do moving forward.